I'm also going to show you problem 113, part A, which is stated quite simply: find the gradient of the function script r squared. Well, we need the function script r squared in terms of x, y, and z. And script r is r minus r prime, where r is the field point and r prime is the source point. So in terms of components, that's x minus x prime x hat plus y minus y prime y hat plus z minus z prime z hat. Script r squared is the magnitude squared of script r, which is x minus x prime squared plus y minus y prime squared plus z minus z prime squared. In the gradient, I'm going to be doing partial derivatives with respect to x, y, and z. The partial derivative with respect to x means, of course, we need to hold y and z constant, but we also need to hold x prime, y prime, and z prime constant when we evaluate the derivative. So the partial derivative of script r squared with respect to x, the only place where x appears in the equation is right here at the beginning. So the partial derivative of this first term with respect to x is 2 times x minus x prime. Similarly, the partial derivative of script r squared with respect to y is 2 y minus y prime, and the partial with respect to z is 2z minus z prime. So the answer is the gradient of script r squared is dr squared dx x hat plus dr squared dy y hat plus dr squared dz z hat. The x component of the gradient is 2 times the x component of script r, and the y component of the gradient is 2 times the y component of script r. So the answer can be written in a very simple way. It's 2 times script r vector.